Welcome back. We are looking at section 2.7, graphing absolute value functions and their graphs. Looking at them, trying to make sense of what they're going to be doing. Now, a couple things, a little background about them. Absolute value functions, they are symmetric, meaning it's like a mirror image. They're equidistant apart, just like those little hearts we made in elementary school when we kind of folded everything, cut around them. They are perfect symmetry. They are symmetric, and we're going to use that to our advantage to make this easier. They have a vertex, meaning that the graphs are going to come to a low point or to a high point, a maximum point or a minimum point, and it's going to form a V. All right? This is going to be the most important point on an absolute value because this is where the line of symmetry goes through. Just very similar to a parabola. Now, when we find our vertex, we can then extend it with two lines to form a V going up or a V going down. And when we start looking at some examples, you'll see what happens there. Now, the parent function that we're going to be using is f of x equals the absolute value of x, written like this. Now remember, absolute values are a way to assess distance. It makes it so we never have a negative distance. So a couple things to remember. Absolute value of 4 is simply 4. Absolute value of negative 3 is positive 3. All of these answers have to be positive. If you want to do negative pi, it's positive pi. So whenever we take the absolute value to go to remove this, this answer will make it positive. Now if we're looking to solve using an absolute value, and again, you might want to pause this just to copy some of this stuff down. Let's say we have this. We have 3 minus 5 plus 7. Now, this 3 minus 5 is inside the absolute value. And I apologize, I see the lights going right across there. I have to fix my production again. But that's a 3 minus 5 in the absolute value, and then plus 7. So we have to evaluate this first. This is a grouping symbol, just like parentheses. Just like parentheses, we have to solve what's inside first. So 3 minus 5 is negative 2. And then we solve plus 7. Now what's the absolute value of negative 2? It is positive 2 plus 7. So our answer is 9. We end up taking this number, adding 7 to make this 9. What comes out of an absolute value will never be negative. So keep that in mind when we start looking at these. Now, thinking back to the last section, when we're talking about transformations, we can still identify and anticipate what our graph will do, whether it's going to shift up, shift left, shift down, shift right, reflect top over the x-axis, or if it's going to stretch or shrink. If we stretch it, it's going to get really thin. If we shrink it, it's going to flatten out. So this is something you want to copy down. This is going to be very important. I would look at this consistently. Right? This is the basic equation of an absolute value function. X minus h plus k. Now, the h and the k, remember the x is the input value, but the h and k we have to find numbers for. The h and k represent our vertex. That's how we find out where our vertex is. They will always be in this form until you hear differently, which won't be for quite a while. So we always want to find this number and this number to start our vertex. And that's how we're going to start graphing these. So if we start with this equation, equation A, f of x equals the absolute value of x minus 4 plus 2. First thing we do, find the vertex. So according to this number is the x value. Remember, it's minus. So this is where a lot of people get confused, but think about what makes this equal to 0. So you can ask yourself, to find your vertex, x minus 4 equals 0. What value will make that true? A positive 4. I'm going to start making an xy chart over here on my left. So it's a positive 4. Now, 4 minus 4 is 0. The reason why we're doing this is because there's only one answer for 0, the absolute value of 0, and that's 0. That's where it's going to come to that point. So 0 plus 2 is 2. There's our vertex. 4, 2. This is where I'm going to start. So it's going to be 4, 2. Now, I want to make an xy chart, but I want to be smart about this. I want to pick points right now 1 unit away to make it easy. So 1 unit bigger than 4 is 5. 1 unit smaller is 3. Now remember that symmetry. If I plug 5 in here, 5 minus 4, and the absolute value is 1. Absolute value of 1 is 1. And 1 plus 2 is 3. Now if I plug in 3, 3 minus 4 is negative 1. The absolute value of negative 1 is positive 1. 1 plus 2 is 3. Look at these two numbers. It is not coincidence that these y values are the same. They're like that because of symmetry. So if I put a 2 in here, I'm going to end up with 4 because I'm 2 units away from 4. This is also going to be 4. If I put a 7 in here, I'm going to get 5, which means it's going to be 1, 5. And we're going to see that symmetric pattern continue. So I have my points. Now remember, I said that these are going to make lines. How many points do we need to make a line? 2. We have our points. 3, 3, and 5, 3. Connect the dots. There's our graph with my vertex at 4, 1. This is the point I'm going to be looking for specifically, right here. 4, 1. Let's try another one. Again, we're going to find our vertex. Oops, I forgot to kind of do this. So we find our vertex. The next step is using an XY chart. Put the vertex in the middle of our chart. And then find two symmetric points. We use two symmetric points. That's how we graph this. So let's say we have f of x equals absolute value x plus 3 plus 1. Find your vertex. What's going to make this equal to 0? What number? If you tell me 3, 3 plus 3 is not 0. It's going to be a negative 3. I'm going to put that in the middle of my XY chart. And then negative 3 plus 3 is 0. 0 plus 1 is 1. Negative 3 comma 1 is the vertex. I'm going to box it up because it's that important. I'm going to highlight it. I'm going to go 1 up and 1 down. Negative 2, negative 4, plug these numbers in. And again, I only have to do one of them because I know what the other answer is going to be the same because it's symmetric. So I'm going to plug in negative 2 plus 3. It's a positive 1. Absolute value of 1 is positive 1. And we get 2. there's my 3 points I need. Negative 2, 2, negative 3, 1, negative 4, 2. So when we graph this, we start at negative 3, positive 1, negative 2, positive 2, negative 4, positive 2, and there's the graph. There's my V. So we will continue to work on these in practice in class. We will continue with this lesson in the next video.